Question 1. Cost-benefit analysis shows that a proposed strategy to significantly reduce raw material inventory levels to minimize holding costs could lead to a substantial increase in ordering costs due to more frequent, smaller purchase orders. Which of the following inventory management approaches best addresses this trade-off to achieve overall cost optimization and operational stability? Option A. Implementing a just-in-time JIT inventory system that relies on frequent, small deliveries from reliable suppliers, carefully balancing holding costs against potential increases in ordering and shortage costs. Option B. Maintaining current raw material inventory levels without any changes, assuming the existing balance of costs is optimal. Option C. Drastically increasing raw material inventory levels to take advantage of bulk purchase discounts and reduce ordering frequency, even if it significantly raises holding costs. Option D. Focusing solely on reducing ordering costs by consolidating all raw material purchases into a single, large annual order. The correct answer is A. Implementing a just-in-time JIT inventory system that relies on frequent, small deliveries from reliable suppliers, carefully balancing holding costs against potential increases in ordering and shortage costs. Explanation. The scenario presents a common challenge in inventory management, balancing the costs associated with holding inventory against the risks of stockouts. Professionals must apply their understanding of inventory fundamentals, including the types of inventory, associated costs, and the implications of inventory turnover, to make informed decisions that align with organizational objectives and regulatory compliance. The challenge lies in interpreting the trade-offs and selecting the approach that best optimizes inventory levels without compromising operational efficiency or incurring undue financial risk. The correct approach involves a thorough evaluation of all relevant inventory costs, holding costs, e.g., warehousing, insurance, obsolescence, ordering costs, e.g., administrative, transportation, and shortage costs, e.g., lost sales, expedited shipping, customer dissatisfaction. It also requires considering the impact of inventory turnover on cash flow and operational responsiveness. By systematically analyzing these factors, a company can determine optimal inventory levels that minimize total inventory costs while meeting demand. This aligns with the CPIM framework's emphasis on efficient resource utilization and cost control, which are implicitly supported by generally accepted accounting principles and sound business practices that guide financial reporting and operational decision-making. An incorrect approach would be to solely focus on minimizing holding costs by drastically reducing inventory levels. This overlooks the potential for increased shortage costs, such as lost sales and damage to customer relationships, which can have a significant negative impact on profitability and market share. Such a decision would be ethically questionable, as it prioritizes short-term cost savings over long-term business sustainability and customer satisfaction. Another incorrect approach is to prioritize minimizing ordering costs by placing very large, infrequent orders. This strategy can lead to excessively high holding costs due to larger average inventory levels, increased risk of obsolescence, and potentially tying up excessive working capital. This approach fails to consider the holistic cost structure of inventory management and can be detrimental to financial health. A further incorrect approach is to ignore the concept of inventory turnover altogether and maintain static inventory levels regardless of demand fluctuations or market conditions. This demonstrates a lack of understanding of inventory's dynamic nature and its impact on operational efficiency and financial performance. It fails to adapt to changing business needs and can lead to either excessive inventory or frequent stockouts, both of which are suboptimal. The professional decision-making process for similar situations involves a structured approach. 1. Define the problem and objectives clearly. 2. Gather relevant data on inventory types, costs, demand patterns, and lead times. 3. Analyze the trade-offs between different inventory strategies, considering all cost components. 4. Evaluate the impact of each strategy on operational performance, financial metrics, and customer service. 5. Select the strategy that best balances costs, risks, and service levels, ensuring alignment with overall business strategy. 6. Continuously monitor and adjust inventory policies based on performance and changing conditions. Question 2. The control framework reveals that a manufacturing company is experiencing challenges with both excessive finished goods inventory and frequent stockouts of critical raw materials. The company's current inventory management relies heavily on historical sales forecasts to drive production and procurement. Management is considering a significant shift in their inventory strategy. Which of the following approaches best addresses the company's dual challenges while adhering to sound inventory management principles? Option A. Introduce consignment inventory for all finished goods and rely solely on vendor-supplied forecasts for raw material procurement. Option B. Transition to a pure push system for all inventory, increasing safety stock levels across the board based on updated forecasts. Option C. Adopt a hybrid inventory management system, utilizing push strategies for predictable raw material replenishment and pull strategies for finished goods based on actual demand. Option D. Implement a comprehensive vendor-managed inventory, VMI system for all raw materials and a strict pull system for finished goods. The correct answer is D. Implement a comprehensive vendor-managed inventory, VMI system for all raw materials and a strict pull system for finished goods. Explanation. This scenario presents a common challenge in inventory management, where a company must balance the benefits of reduced holding costs and improved efficiency against the risks of stockouts and potential disruptions to production. The professional challenge lies in selecting an inventory management system that aligns with the company's strategic goals, operational capabilities, and the specific demands of its customer base, all while adhering to industry best practices and any relevant regulatory guidelines for inventory accuracy and reporting. Careful judgment is required to avoid over-reliance on a single system and to ensure flexibility. The correct approach involves implementing a hybrid system that leverages the strengths of both push and pull strategies. A push system, driven by forecasted demand, can be effective for managing raw materials and components with predictable usage patterns, ensuring availability for production. Simultaneously, a pull system, triggered by actual customer orders or downstream production needs, is ideal for finished goods and customized items, minimizing excess inventory and obsolescence. This balanced approach, often supported by inventory optimization software, allows for proactive material procurement while maintaining responsiveness to market fluctuations, thereby enhancing overall supply chain efficiency and customer satisfaction. This aligns with the CPIM principles of optimizing inventory levels to meet demand while minimizing costs and risks. An incorrect approach would be to exclusively adopt a pure push system for all inventory. This could lead to significant overstocking of finished goods if forecasts are inaccurate, resulting in increased holding costs, potential obsolescence, and wasted capital. Ethically, it could also lead to inefficient resource allocation. Another incorrect approach is to solely rely on a pure pull system without adequate buffer stock for critical components. This risks frequent stockouts, production stop-downs, and missed customer orders, damaging the company's reputation and potentially violating contractual obligations. Implementing vendor-managed inventory, VMI, or consignment inventory without a thorough understanding of supplier capabilities, contractual agreements, and internal control mechanisms can also be problematic. VMI, if not properly managed, can lead to a loss of control over inventory levels and potentially higher costs if the vendor's incentives are not aligned with the company's. Consignment inventory, if not accurately tracked and accounted for, can lead to discrepancies in financial reporting and potential disputes with the supplier. Professionals should approach this decision by first conducting a thorough analysis of demand patterns, lead times, supplier reliability, and production processes. They should then evaluate various inventory management systems, considering their suitability for different inventory categories. The use of inventory optimization software can aid in this evaluation by providing data-driven insights. A phased implementation, starting with pilot programs for new systems, is advisable to mitigate risks. Continuous monitoring and adjustment of inventory policies based on performance metrics are crucial for sustained success. Question 3. Operational review demonstrates that a potential new supplier can offer significant cost savings on a critical component. However, this supplier is relatively unknown and has not undergone the company's standard supplier qualification process. The current supplier, while more expensive, has a long-standing relationship and a proven track record of quality and reliability. Management is pushing for an immediate decision to capitalize on the cost savings. Which of the following approaches best aligns with sound supply chain management principles and CPIM Part 1 foundational knowledge? Option A. Delay the decision and continue to gather more information about the new supplier without a structured evaluation plan, while maintaining the current supplier relationship. Option B. Immediately switch to the new supplier to realize the cost savings, assuming that the lower price indicates comparable or better value. Option C. Conduct a comprehensive risk assessment and due diligence on the potential new supplier, including site visits, quality audits, and verification of ethical labor practices, before making any decision. Option D. Inform management that the cost savings are not a priority and that the company should continue with the current, more expensive supplier without further investigation. Correct answer is C. Conduct a comprehensive risk assessment and due diligence on the potential new supplier, including site visits, quality audits, and verification of ethical labor practices, before making any decision. Explanation: this scenario is professionally challenging because it requires balancing immediate cost-saving pressures with long-term supply chain resilience and ethical sourcing, all within the context of APIC CPIM Part 1 foundational principles. The pressure to reduce costs by sourcing from a new, unvetted supplier could jeopardize product quality, lead to disruptions, and potentially involve unethical labor practices, which are critical considerations in supply chain management. Careful judgment is required to avoid short-sighted decisions that could have significant negative repercussions. The correct approach involves conducting a thorough risk assessment and due diligence on the potential new supplier. This includes evaluating their quality control processes, financial stability, ethical labor practices, and their ability to meet delivery schedules consistently. This approach aligns with the APIC CPIM framework's emphasis on understanding the entire supply chain, managing risks, and ensuring ethical and sustainable operations. It prioritizes long-term supply chain health and reputation over immediate cost savings, reflecting professional responsibility and adherence to best practices in production and inventory management. An incorrect approach that focuses solely on the lowest price without adequate vetting fails to address potential risks such as poor quality, unreliable delivery, or unethical sourcing. This could lead to increased costs due to rework, customer dissatisfaction, and reputational damage, violating the principle of responsible supply chain management. Another incorrect approach that involves immediately switching suppliers based on the cost reduction proposal, without any verification of the new supplier's capabilities or compliance, demonstrates a lack of due diligence. This can result in significant disruptions to production, inventory shortages, and potential legal or ethical liabilities if the new supplier engages in non-compliant practices. A third incorrect approach that involves delaying the decision indefinitely while continuing to explore the new supplier without a structured evaluation process is also problematic. This indecisiveness can lead to missed opportunities for cost savings if the new supplier is indeed viable, or it can prolong the risk of continuing with a potentially less reliable current supplier. It signifies a failure to proactively manage the supply chain and make informed decisions. Professionals should employ a structured decision-making process that begins with clearly defining the objectives, e.g., cost reduction, improved reliability. This should be followed by a comprehensive evaluation of all potential solutions, including a thorough risk assessment and due diligence for any new suppliers. The decision should be based on a holistic view of the supply chain, considering not only cost but also quality, reliability, ethical considerations, and long-term strategic alignment. Documenting the evaluation process and the rationale for the final decision is crucial for accountability and future reference. Question 4. Operational review demonstrates that a key supplier, while meeting cost targets, has recently been flagged for potential labor practice violations by an independent audit. This supplier is critical for a significant portion of the company's product components, and switching to an alternative would incur substantial immediate costs and potential delivery delays. The company is facing strong pressure from senior management to reduce operational expenses in the next fiscal quarter. Which of the following approaches best aligns with developing a resilient and ethically sound supply chain strategy in this situation? Option A. Immediately source from a new, lower-cost supplier identified by the procurement team, prioritizing short-term cost savings to meet management's financial targets. Option B. Continue with the current supplier without further investigation, assuming the audit findings are minor and will not impact operations or the company's reputation. Option C. Initiate a thorough investigation into the supplier's labor practices, engage with the supplier to develop a corrective action plan, and explore phased cost reduction strategies that do not compromise ethical standards or supply continuity. Option D. Terminate the contract with the current supplier immediately and halt production until a fully vetted, lower-cost alternative is secured. The correct answer is C. Initiate a thorough investigation into the supplier's labor practices, engage with the supplier to develop a corrective action plan, and explore phased cost reduction strategies that do not compromise ethical standards or supply continuity. Explanation. This scenario presents a professional challenge because it forces a decision between short-term cost savings and long-term supply chain resilience and ethical sourcing, potentially impacting the company's reputation and its ability to meet future business goals. The pressure to meet immediate financial targets can create a conflict with the strategic imperative of building a robust and responsible supply chain. Careful judgment is required to balance competing priorities and ensure alignment with the company's overall business strategy and ethical commitments. The correct approach involves prioritizing the development of a supply chain strategy that aligns with the company's stated business goals, including competitive priorities like quality and delivery, while also incorporating robust risk management and ethical sourcing practices. This approach recognizes that a sustainable supply chain is built on a foundation of ethical conduct and resilience, not solely on cost reduction. By engaging with suppliers to understand and mitigate risks, and by ensuring compliance with relevant ethical sourcing guidelines, which, for the CPIM exam, would implicitly refer to generally accepted ethical business practices and any specific industry codes of conduct that are part of the curriculum, the company safeguards its long-term viability and reputation. This aligns with the CPIM framework's emphasis on strategic alignment and responsible operations. An incorrect approach that focuses solely on immediate cost reduction by switching to a lower-cost supplier without adequate due diligence fails to consider the broader implications. This could lead to significant quality issues, delivery disruptions, and reputational damage if the new supplier has poor labor practices or environmental standards. Such a decision would violate the principle of aligning supply chain strategy with business goals, particularly if quality and delivery are competitive priorities. It also neglects the critical aspect of risk management, potentially exposing the company to unforeseen disruptions and ethical breaches. Another incorrect approach, which involves maintaining the status quo without investigating the supplier's practices, is also professionally unacceptable. This passive stance ignores potential risks and ethical concerns that could surface later, leading to a crisis. It demonstrates a lack of proactive supply chain management and a failure to uphold ethical responsibilities, which are integral to a sound supply chain strategy. A third incorrect approach, which is to immediately terminate the relationship without attempting to understand or resolve the issues, might seem decisive but can be detrimental. While ethical breaches must be addressed, a hasty termination without exploring collaborative solutions or understanding the root cause can damage supplier relationships, disrupt supply, and potentially lead to legal or contractual complications. It also misses an opportunity to improve the supplier's practices and strengthen the supply chain collaboratively, which is a more strategic and ethical approach. The professional decision-making process for similar situations should involve a structured approach. 1. Understand the business goals and competitive priorities. 2. Assess the current supply chain's alignment with these goals. 3. Identify potential risks and ethical considerations within the supply chain. 4. Gather information and conduct due diligence on suppliers, especially when cost pressures arise or concerns are identified. 5. Evaluate the impact of potential decisions on cost, quality, delivery, flexibility, and innovation. 6. Prioritize long-term resilience and ethical conduct alongside financial performance. 7. Engage in open communication with suppliers to address issues and seek collaborative solutions where appropriate. 8. Document all decisions and the rationale behind them. Question 5. Governance review demonstrates that the company's inventory control system is experiencing frequent stockouts for high-demand items and excessive holding costs for slow-moving items. The inventory team proposes several strategies to address these issues. Which of the following integrated approaches best aligns with the principles of effective inventory management as emphasized by the CPIM framework? Option A. Implement a rigorous cycle counting program for all inventory, coupled with an ABC classification system to prioritize counting efforts on high-value items, and adjust safety stock levels based on updated demand forecasts and lead time variability. Option B. Transition to an annual physical inventory count for all items and eliminate cycle counting to reduce labor costs associated with inventory verification. Option C. Apply the economic order quantity (EOQ) formula to all purchased items without further analysis of demand patterns or supplier reliability. Option D. Significantly reduce safety stock levels across all inventory categories to minimize holding costs, assuming that demand will stabilize in the near future. The correct answer is A. Implement a rigorous cycle counting program for all inventory, coupled with an ABC classification system to prioritize counting efforts on high-value items, and adjust safety stock levels based on updated demand forecasts and lead time variability. Explanation. This scenario presents a common challenge in inventory management, where different techniques are proposed to address inventory control issues. The professional challenge lies in selecting the most appropriate and compliant approach given the specific context and regulatory environment. Careful judgment is required to balance efficiency, cost-effectiveness, and adherence to established inventory management principles, which are implicitly governed by the CPIM framework's emphasis on best practices and operational integrity. The correct approach involves implementing a multifaceted strategy that combines ABC classification for prioritization, cycle counting for ongoing accuracy, and appropriate safety stock calculations to mitigate stockouts, all within the overarching goal of optimizing inventory levels. This aligns with CPIM principles by promoting proactive management, data-driven decision-making, and continuous improvement in inventory accuracy and availability. The regulatory framework for CPIM, while not a specific legal code, emphasizes adherence to established best practices and ethical conduct in production and inventory management, which this approach upholds by ensuring efficient resource utilization and customer satisfaction through reliable stock availability. An approach that solely focuses on reducing safety stock without considering demand variability or lead times is ethically flawed, as it prioritizes cost reduction over operational reliability, potentially leading to stockouts and customer dissatisfaction, which is contrary to the CPIM aim of efficient and effective operations. Relying exclusively on annual physical inventory without implementing cycle counting is also problematic. While a physical inventory provides a snapshot, its infrequency makes it prone to significant errors accumulating between counts, failing to meet the CPIM standard for maintaining accurate inventory records throughout the year. Implementing EOQ without considering its assumptions or limitations, such as constant demand and lead times, can lead to suboptimal ordering decisions and increased costs, deviating from the CPIM focus on practical and effective application of inventory models. Professionals should approach such situations by first understanding the underlying inventory control objectives and constraints. They should then evaluate each proposed technique's alignment with CPIM principles, considering its impact on accuracy, cost, and service level. A comparative analysis of the strengths and weaknesses of each technique in the specific operational context, coupled with an understanding of the implicit ethical obligations to maintain operational efficiency and customer trust, will guide the selection of the most robust and compliant strategy. Question 6. What factors determine the appropriate level of responsiveness of the Master Production Schedule, MPS, to changes in customer demand, considering the impact of time fences and the distinction between available to promise at and capable to promise CTP? Option A. The total quantity of the demand change, regardless of its timing relative to the MPS or available capacity. Option B. The urgency expressed by the sales team, irrespective of its alignment with production capabilities or material availability. Option C. The historical average demand for the product, without considering current market signals or production constraints. Option D. The proximity of the demand change to the current production date, the capacity available within the planning time fence, and the potential impact on downstream operations. Correct answer is D. The proximity of the demand change to the current production date, the capacity available within the planning time fence, and the potential impact on downstream operations. Explanation. Scenario analysis. This scenario presents a common challenge in production and inventory management, balancing the need for MPS stability with the imperative to respond to actual customer demand. The professional challenge lies in accurately assessing the impact of demand fluctuations on the MPS and making informed decisions about when and how to adjust it without causing excessive disruption to production and the supply chain. Overly rigid adherence to the MPS can lead to lost sales and customer dissatisfaction, while excessive reactivity can result in increased costs, schedule instability, and potential obsolescence of inventory. Careful judgment is required to navigate these competing priorities effectively. Correct approach analysis. The correct approach involves a dynamic yet controlled adjustment of the MPS based on a thorough understanding of demand signals and their proximity to the current production plan, particularly within the defined time fences. This approach prioritizes maintaining stability within the firm order zone and the planning time fence by absorbing minor fluctuations through existing inventory or short-term capacity adjustments. For demand changes outside these zones, a more significant MPS revision may be warranted, but only after a comprehensive impact analysis on capacity, materials, and downstream operations. This aligns with the principles of effective MPS management, which aims to provide a realistic and achievable production plan that meets customer needs while minimizing operational disruptions and costs. The regulatory framework for CPIM emphasizes the importance of a well-managed MPS as a cornerstone of efficient production planning, directly impacting customer service levels and profitability. Incorrect approaches analysis. One incorrect approach is to rigidly adhere to the MPS regardless of significant demand changes, especially those occurring outside the firm order zone. This failure to adapt to market realities can lead to stockouts, missed sales opportunities, and a decline in customer satisfaction, violating the implicit ethical obligation to serve customers effectively. Another incorrect approach is to make frequent and drastic changes to the MPS in response to every minor demand fluctuation. This creates schedule instability, leading to increased expediting costs, potential material obsolescence, and a breakdown in communication and trust with manufacturing and suppliers, which is contrary to the principles of sound production planning and inventory management. A third incorrect approach is to solely rely on available-to-promise-at figures without considering the underlying capacity constraints or the impact on future production. This can lead to overpromising and underdelivering, damaging customer relationships and operational efficiency, and is a failure to properly implement the MPS as a realistic plan. Professional reasoning. Professionals should adopt a decision-making process that begins with understanding the current MPS and its associated time fences. When demand signals change, the first step is to assess the magnitude and timing of the change relative to these fences. For changes within the firm order zone, focus on managing existing commitments and potential short-term adjustments. For changes outside this zone, conduct a thorough impact analysis, considering capacity, material availability, and the potential ripple effects on other production schedules and the supply chain. This analysis should inform a decision on whether to adjust the MPS, and if so, how to do so in a controlled and communicated manner. Collaboration with sales, operations, and supply chain teams is crucial throughout this process to ensure alignment and minimize disruption. Question 7. Examination of the data shows that the sales team has presented a demand forecast for the upcoming quarter that is 20% higher than the previous quarter, citing new market opportunities and aggressive promotional activities. However, the operations team has indicated that current production capacity, even with overtime, can only support a 5% increase in output. The S&OP manager needs to facilitate a meeting to reconcile these figures and develop a feasible plan. Which of the following actions best represents the appropriate next step in the S&OP process? Option A. The S&OP manager should direct the operations team to find ways to increase capacity by at least 15% to meet the sales forecast, regardless of the immediate cost implications. Option B. The S&OP manager should lead a collaborative session where sales presents the rationale behind their forecast, operations details their capacity constraints and potential solutions, and both teams work together to identify trade-offs, prioritize demand, and explore options like inventory adjustments or phased fulfillment to reach a consensus plan. Option C. The S&OP manager should accept the sales forecast as presented and instruct operations to do their best to meet it, deferring any discussions about feasibility until after the plan is finalized. Option D. The S&OP manager should instruct the sales team to revise their forecast downwards to match the operational capacity, emphasizing that the plan must be achievable from a production standpoint. Correct answer is B. The S&OP manager should lead a collaborative session where sales presents the rationale behind their forecast, Operations details their capacity constraints and potential solutions, and both teams work together to identify trade-offs, prioritize demand, and explore options like inventory adjustments or phased fulfillment to reach a consensus plan. Explanation: this scenario presents a common challenge in demand planning, reconciling conflicting information from sales and operations during the sales and operations planning S and OP process. The professional challenge lies in ensuring that the S and OP plan is realistic, achievable, and aligned with both market demand and production capabilities, while also adhering to ethical considerations of transparency and data integrity. A robust S and OP process requires a structured approach to demand review, supply review, and reconciliation to prevent misaligned plans that can lead to stockouts, excess inventory, and damaged customer relationships. The correct approach involves a thorough demand review where sales provides insights into market trends, customer feedback, and promotional impacts, followed by a supply review where operations assesses current capacity, lead times, and potential constraints. The critical step is the reconciliation meeting, where these two perspectives are brought together to identify gaps and collaboratively develop a consensus plan. This collaborative approach is fundamental to effective S and OP, ensuring that the plan is both aspirational and grounded in reality. Ethically, this process promotes transparency and accountability across departments, fostering trust and shared ownership of the plan. Regulatory frameworks, while not explicitly dictating S and OP procedures, implicitly support such practices through requirements for accurate financial reporting and operational efficiency, which are compromised by poorly planned inventory and production. An incorrect approach would be to simply accept the sales forecast without rigorous validation against operational capabilities. This fails to acknowledge the supply constraints and can lead to an unrealistic plan that promises more than can be delivered, potentially resulting in unmet demand and customer dissatisfaction. Ethically, this can be seen as misleading stakeholders about the company's ability to meet commitments. Another incorrect approach is to prioritize operational capacity over market demand without understanding the implications for sales and revenue. This can lead to missed market opportunities and a failure to capitalize on demand, which is detrimental to business growth and can be viewed as a failure of fiduciary responsibility to maximize shareholder value. Finally, bypassing the reconciliation meeting and unilaterally imposing a plan from either sales or operations ignores the collaborative nature of S and OP and can create internal friction and a lack of buy-in, undermining the effectiveness of the entire process and potentially leading to compliance issues if the resulting operational decisions violate internal policies or external agreements. Professionals should approach this situation by first understanding the core purpose of S and OP, to balance demand and supply to create a single, integrated plan. The decision-making process should involve 1. Clearly defining the inputs for both the demand review and supply review. 2. Facilitating open and honest communication during the reconciliation meeting, encouraging data-driven discussions. 3. Documenting all assumptions, decisions, and action items. 4. Establishing clear metrics to track the performance of the S and OP plan and identify areas for continuous improvement. This structured and collaborative approach ensures that the resulting plan is robust, executable, and aligned with the company's strategic objectives. Question 8. When evaluating the effectiveness of demand forecasting for a new product line with highly variable historical sales data, which approach best aligns with CPIM principles for ensuring reliable predictions and mitigating operational risks? Option A. Utilizing only expert opinions from the sales team without any quantitative analysis of historical data. Option B. Employing a combination of exponential smoothing and Delphi method, coupled with regular monitoring of forecast accuracy using MAPE and MAD. Option C. Solely relying on a simple moving average based on the most recent 3 months of sales data. Option D. Implementing a trend projection method without considering potential market shifts or seasonality. Correct answer is B. Employing a combination of exponential smoothing and Delphi method, coupled with regular monitoring of forecast accuracy using MAPE and MAD. Explanation: this scenario presents a professional challenge because the company is relying on a single forecasting method without considering its limitations or the potential impact of external factors. This lack of a comprehensive approach can lead to inaccurate forecasts, resulting in suboptimal inventory levels, production schedules, and ultimately, financial performance. The CPIM framework emphasizes a holistic understanding of demand forecasting, including the selection of appropriate methods based on data availability, product lifecycle, and market dynamics. The correct approach involves a multifaceted strategy that combines qualitative and quantitative methods, and critically, includes a robust process for monitoring forecast accuracy and making necessary adjustments. This aligns with the CPIM principles of continuous improvement and data-driven decision-making. By utilizing multiple forecasting techniques and regularly assessing their accuracy using metrics like MAD, MSC, and MAPE, the company can gain a more reliable understanding of future demand. Furthermore, incorporating qualitative insights from sales and marketing teams helps to account for factors not captured by historical data, such as new product launches or competitor actions. This integrated approach is ethically sound as it promotes responsible resource allocation and minimizes the risk of financial losses due to poor forecasting. An incorrect approach would be to solely rely on a single quantitative method, such as a simple moving average, without considering its suitability for the product's demand pattern or without incorporating qualitative insights. This fails to acknowledge that historical data may not always be a perfect predictor of future demand, especially for products with volatile sales or in rapidly changing markets. Ethically, this can be seen as negligent if it leads to significant overstocking or stockouts, impacting customer satisfaction and company profitability. Another incorrect approach is to exclusively use qualitative methods, like expert opinion, without any quantitative validation. While expert opinions can be valuable, they are subjective and prone to biases. Without grounding these opinions in historical data or statistical analysis, the forecast can become speculative and unreliable. This can lead to inefficient operational planning and potentially misrepresent the true demand to stakeholders, which is an ethical concern regarding transparency and accuracy. Finally, an incorrect approach would be to ignore forecast accuracy metrics altogether. Relying on a forecast without measuring its performance is akin to flying blind. It prevents the identification of systematic errors or biases in the forecasting process, hindering any opportunity for improvement. This lack of diligence can lead to repeated forecasting errors, impacting operational efficiency and financial health, and is a failure in professional responsibility to ensure the best possible use of company resources. The professional decision-making process should involve 1. Understanding the characteristics of the product and its market, e.g., life cycle stage, demand variability, seasonality. 2. Evaluating the availability and quality of historical data. 3. Selecting a combination of forecasting methods that best suit the product and data characteristics. 4. Establishing a system for tracking forecast accuracy using appropriate metrics. 5. Regularly reviewing forecast performance and making adjustments to methods or parameters as needed. 6. Incorporating qualitative insights from relevant stakeholders to refine quantitative forecasts. Question 9. Process analysis reveals significant delays and quality issues in the assembly department. A cross-functional team has been tasked with improving the situation using lean principles. They have identified several potential solutions, including reducing the number of inspection points, increasing the speed of the assembly line, and implementing a new visual management system. Which of the following approaches best aligns with the CPIM framework's emphasis on responsible and sustainable improvement? Option A. Prioritize the implementation of the new visual management system after conducting a detailed value stream map to identify all forms of waste and potential for Mura and Muri, and then pilot test the system with a focus on standardized work and continuous feedback. Option B. Immediately reduce the number of inspection points to decrease cycle time and cost, assuming that the assembly line speed will compensate for any potential quality dips. Option C. Implement the new visual management system and simultaneously increase assembly line speed without a thorough analysis of the value stream, potential impact on workforce workload. Option D. Increase the speed of the assembly line significantly to process more units in less time, with the expectation that any resulting quality issues can be addressed later through rework. The correct answer is A. Prioritize the implementation of the new visual management system after conducting a detailed value stream map to identify all forms of waste and potential for Mura and Muri, and then pilot test the system with a focus on standardized work and continuous feedback. Explanation. This scenario presents a professional challenge because it requires balancing the pursuit of efficiency gains through lean principles with the ethical obligation to ensure that proposed improvements do not inadvertently create new risks or negatively impact the workforce. The CPIM framework emphasizes a holistic approach to production and inventory management, where efficiency must be achieved responsibly and sustainably. Careful judgment is required to distinguish between genuine waste reduction and actions that could lead to overburdening (MURI) or inconsistency (MURA), which are explicitly addressed in lean principles as forms of waste to be eliminated. The correct approach involves a systematic and data-driven evaluation of proposed changes, focusing on identifying and eliminating the 7 wastes (MUDA), while ensuring that the remaining processes are stable and predictable. This aligns with the core tenets of Lean, particularly the emphasis on continuous improvement Kaizen and the structured methodology of 5s for workplace organization. Standardized work is crucial for maintaining consistency and providing a baseline for further improvement. By focusing on value stream mapping to understand the flow of value and identifying non-value-adding activities, the team can propose targeted improvements that enhance efficiency without compromising quality or creating undue stress on personnel. This approach is ethically sound, as it prioritizes the long-term health and effectiveness of the production system and its people. An incorrect approach would be to prioritize speed or cost reduction above all else, without a thorough understanding of the value stream or the potential for introducing MURA or MURI. For instance, simply reducing buffer stock without analyzing the upstream and downstream impacts could lead to increased variability and potential stockouts, creating a form of waste itself and potentially leading to rushed work (MURI). Another incorrect approach would be to implement 5s without proper training or buy-in from the workforce, leading to superficial compliance rather than genuine engagement and sustainable change. This fails to leverage the full potential of Kaizen and can lead to a perception of top-down mandates rather than collaborative improvement. Implementing standardized work without first understanding the current state and identifying opportunities for improvement can also be counterproductive, potentially codifying inefficient practices. The professional decision-making process for similar situations should involve a structured risk assessment integrated with lean principles. This begins with a thorough value stream mapping exercise to understand the current state and identify all forms of waste. Next, potential improvements should be evaluated not only for their impact on efficiency, but also for their potential to introduce MURA or MURI. Pilot testing of proposed changes, followed by rigorous data collection and analysis, is essential before full-scale implementation. Engaging the workforce at all stages of the process, from identification of waste to the development and implementation of solutions, fosters ownership and ensures that improvements are practical and sustainable. This iterative process of Plan, Do, Check, Act (PDCA) is fundamental to continuous improvement and responsible operational management. Question 10. Risk assessment procedures indicate a need to reduce inventory carrying costs. The current inventory management system relies on annual physical inventory counts, which are resource-intensive. Management is considering eliminating the annual physical count and relying solely on system-generated inventory records to reduce immediate expenses. What is the most professionally responsible approach to address this directive while maintaining inventory accuracy? Option A. Reduce the frequency of physical inventory counts to once every 2 years and reallocate the saved resources to other operational areas. Option B. Eliminate the annual physical inventory count and instruct warehouse staff to focus on order fulfillment, assuming system records are sufficiently accurate for cost-saving purposes. Option C. Accept vendor-provided inventory data as the primary source for inventory valuation and planning, reducing internal verification efforts. Option D. Implement a structured cycle counting program, prioritizing high-value and high-turnover items, and use the results to continuously improve inventory record accuracy. The correct answer is D. Implement a structured cycle counting program, prioritizing high-value and high-turnover items, and use the results to continuously improve inventory record accuracy. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for cost reduction with the long-term implications for inventory accuracy and operational efficiency, all within the context of APEX. Now ASCM, CPIM Part 1 Principles. The pressure to demonstrate cost savings can lead to shortcuts that undermine the integrity of inventory data, which is foundational to effective production and inventory management. Careful judgment is required to ensure that cost-saving measures do not compromise the reliability of inventory records, which can lead to stockouts, excess inventory, production delays, and increased expediting costs. The correct approach involves a phased implementation of cycle counting, prioritizing high-value or high-turnover items first, and integrating it with ongoing inventory record accuracy initiatives. This method aligns with CPIM principles by focusing on data accuracy as a prerequisite for effective planning and control. It allows for gradual improvement, provides opportunities to identify and address root causes of inaccuracies, and minimizes disruption to ongoing operations. This approach is ethically sound as it upholds the professional responsibility to maintain accurate data, which is crucial for informed decision-making and operational integrity. It also aligns with the spirit of continuous improvement emphasized in production and inventory management. An incorrect approach that focuses solely on reducing the frequency of physical inventory counts without implementing a robust alternative like cycle counting would be professionally unacceptable. This failure stems from a misunderstanding of inventory management principles, as it neglects the critical need for ongoing verification of inventory records. Such an approach risks significant data degradation, leading to poor planning, increased costs due to stockouts or excess, and a loss of credibility for the inventory management function. Ethically, it represents a dereliction of duty to maintain accurate records. Another incorrect approach that involves reducing the number of warehouse staff responsible for inventory record keeping without addressing the underlying processes or implementing technology to compensate would also be professionally unsound. This approach prioritizes headcount reduction over process integrity and data accuracy. It ignores the fact that accurate inventory records are a result of diligent processes and sufficient resources, not just headcount. The ethical failure lies in creating an environment where accurate record keeping is impossible due to insufficient resources, leading to operational failures and potential financial losses for the organization. A third incorrect approach that involves relying solely on vendor-provided inventory data without independent verification would be professionally irresponsible. While vendor data can be a useful input, it should not be the sole source of truth for an organization's inventory. This approach abdicates the responsibility for maintaining internal inventory accuracy and exposes the organization to risks associated with vendor errors, data transmission issues, or misaligned reporting. Ethically, it fails to exercise due diligence in safeguarding the organization's assets and operational continuity. Professionals should employ a decision-making framework that prioritizes data accuracy and operational effectiveness over short-term cost savings. This involves understanding the root causes of inventory inaccuracies, evaluating the impact of proposed changes on data integrity, and implementing solutions that are sustainable and aligned with best practices in inventory management. A thorough risk assessment, stakeholder consultation, and a phased implementation plan are crucial steps in making sound professional decisions. Question 11. Regulatory review indicates that a certified in production and inventory management, CPIM, professional has discovered a significant discrepancy between the physical inventory count of a critical component and the quantity recorded in the inventory management system, which is used as input for material requirements planning, MRP. The production schedule is imminent, and there is pressure to proceed with the MRP run to avoid delays. The CPIM professional suspects the system data is incorrect, but has not yet completed a full investigation into the root cause. Which of the following actions best aligns with ethical and professional CPIM practice? Option A. Proceed with the MRP run using the existing system data, assuming the discrepancy will be resolved through subsequent cycle counts or adjustments to avoid production delays. Option B. Immediately adjust the system inventory records to match the physical count, assuming the physical count is accurate, and proceed with the MRP run to meet the production schedule. Option C. Escalate the discrepancy to management, clearly documenting the observed difference and the need for further investigation before proceeding with the MRP run, even if it causes a minor delay. Option D. Inform the warehouse supervisor that the discrepancy is likely due to their team's errors and instruct them to correct the system records before the MRP run. The correct answer is B. Immediately adjust the system inventory records to match the physical count, assuming the physical count is accurate, and proceed with the MRP run to meet the production schedule. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for accurate inventory data with the ethical obligation to report truthfully and avoid misleading stakeholders. The pressure to meet production schedules can create a temptation to manipulate data, which directly conflicts with the principles of integrity and professional conduct expected of CPIM professionals. Careful judgment is required to uphold ethical standards even when facing operational pressures. The correct approach involves immediately escalating the discrepancy to the appropriate management level and documenting the findings. This upholds the ethical principle of honesty and transparency. By reporting the issue promptly and accurately, the CPIM professional ensures that decisions are based on reliable data, preventing potential downstream problems and maintaining stakeholder trust. This aligns with the APEX, now ASCOM, Code of Ethics, which emphasizes integrity, honesty, and professional responsibility in all business dealings. An incorrect approach would be to adjust the MRP input data without proper investigation or authorization to make it appear as though the physical count aligns with system records. This is a direct violation of ethical principles, as it involves falsifying information. Such an action undermines the integrity of the planning system and can lead to incorrect production orders, stockouts, or excess inventory, ultimately harming the organization and its stakeholders. It also breaches the professional responsibility to ensure data accuracy. Another incorrect approach is to ignore the discrepancy and proceed with the current MRP run, hoping the issue resolves itself or is not noticed. This demonstrates a lack of professional responsibility and integrity. By failing to address a known data inaccuracy, the CPIM professional allows flawed information to drive critical production and inventory decisions, which can have significant financial and operational consequences. This passive approach also fails to uphold the duty to act in the best interest of the organization. A third incorrect approach would be to blame the warehouse staff for the discrepancy without a thorough investigation. While human error can occur, making assumptions and assigning blame without evidence is unprofessional and unethical. It bypasses the necessary process of root cause analysis and can damage interdepartmental relationships. The professional responsibility is to identify the root cause of the discrepancy, not to prematurely assign fault. The professional decision-making process for similar situations should involve 1. Acknowledging the discrepancy and its potential impact. 2. Investigating the root cause of the discrepancy thoroughly and objectively. 3. Documenting all findings and actions taken. 4. Escalating the issue to the appropriate level of management with clear factual information. 5. Recommending corrective actions to prevent recurrence. 6. Adhering strictly to the organization's policies and the APEX, now ASCOM, Code of Ethics throughout the process. Question 12. The efficiency study reveals a consistent pattern of minor cosmetic flaws in the finished goods, leading to a slight increase in customer complaints. The production manager needs to understand the underlying reasons for these flaws to implement corrective actions. Which quality control tool would be most effective for the initial stage of brainstorming and categorizing all potential contributing factors to these cosmetic flaws? Option A, process capability analysis. Option B, control chart. Option C, cause and effect diagram, fishbone diagram. Option D, Pareto chart. Correct answer is C, cause and effect diagram, fishbone diagram. Explanation. The efficiency study reveals a recurring issue with product defects, impacting customer satisfaction and potentially leading to increased warranty claims. This scenario is professionally challenging because it requires the production manager to not only identify the root cause of the defects, but also to select the most effective quality control tool for analysis and communication. Adhering to established APEX, now ASCOM, principles for CPIM certification. The challenge lies in moving beyond mere identification of problems to implementing a structured approach for problem solving and continuous improvement, which is a core tenet of production and inventory management. The correct approach involves utilizing a cause and effect diagram, fishbone diagram, to systematically explore all potential causes of the defects. Categorized into logical groups, this tool is ideal for brainstorming and organizing potential root causes when the source of variation is not immediately obvious. It aligns with APEX principles by promoting a thorough, data-driven investigation before implementing solutions. The regulatory and ethical justification stems from the commitment to producing quality products, minimizing waste, and ensuring customer satisfaction, all of which are implicitly supported by APIC's best practices that emphasize process control and improvement. An incorrect approach would be to immediately implement a control chart without a clear understanding of the process variation or the specific parameters to monitor. While control charts are essential for monitoring process stability, they are most effective when applied to a process where the key variables and their expected variation are understood. Using a control chart prematurely might lead to misinterpretation of data or an inability to identify the true root cause if the wrong variables are being tracked. This fails to adhere to the structured problem-solving approach advocated by APICs. Another incorrect approach would be to solely rely on a Pareto chart to identify the vital few causes without first understanding the full spectrum of potential contributing factors. A Pareto chart is excellent for prioritizing problems or causes once they have been identified and quantified, but it does not inherently help in discovering those causes in the first place. This approach bypasses the critical diagnostic step of root cause analysis, which is fundamental to effective quality management and APICS principles. Finally, focusing solely on process capability analysis without understanding the underlying process behavior is also an incorrect approach. Process capability analysis measures how well a process meets specifications, but it assumes the process is stable and in statistical control. If the process is not understood or controlled, capability indices can be misleading. This neglects the foundational steps of process understanding and control that APICS emphasizes. The professional decision-making process for similar situations should involve a systematic approach. First, clearly define the problem. Second, gather relevant data. Third, use diagnostic tools like cause and effect diagrams to explore potential root causes. Fourth, use tools like Pareto charts to prioritize identified causes. Fifth, implement control charts to monitor the process and ensure stability. And finally, use process capability analysis to assess performance against specifications. This structured, iterative approach ensures that solutions are targeted and effective, aligning with the principles of continuous improvement central to CPIM certification. Question 13. The evaluation methodology shows that the production team is experiencing increased customer complaints related to product defects. Management is pushing for immediate cost reductions. The quality manager is considering several strategies to address the situation. Which strategy best aligns with the principles of total quality management, TQM, and continuous improvement within the CPIM framework? Option A. Reduce the frequency of final product inspections to expedite the shipping process and lower appraisal costs. Option B. Implement a rigorous program of employee training on quality standards and invest in enhanced process monitoring equipment to identify potential issues early. Option C. Cut back on employee training initiatives related to quality control to reallocate resources to production line speed enhancements. Option D. Accept a slightly higher tolerance for minor defects to accelerate the manufacturing cycle and reduce lead times. The correct answer is B. Implement a rigorous program of employee training on quality standards and invest in enhanced process monitoring equipment to identify potential issues early. Explanation. This scenario is professionally challenging because it requires balancing immediate cost pressures with long-term quality objectives, a common dilemma in production and inventory management. The pressure to reduce costs can lead to shortcuts that compromise quality, potentially increasing failure costs and damaging customer relationships. Careful judgment is required to identify the most effective quality strategy that aligns with the CPIM framework's emphasis on integrated processes and customer satisfaction. The correct approach involves recognizing that investing in prevention and appraisal activities, as advocated by Total Quality Management (TQM) principles, is crucial for reducing overall costs of quality. Prevention costs, such as training and process design, and appraisal costs, like inspections and testing, are designed to identify and mitigate potential defects before they occur. This proactive stance, aligned with continuous improvement philosophies, ultimately leads to lower failure costs, internal and external, and enhances product reliability and customer satisfaction, which are core tenets of effective production and inventory management as outlined in CPIM Part 1. An incorrect approach that focuses solely on reducing appraisal costs by decreasing inspection frequency is professionally unacceptable. This directly contradicts the principles of quality assurance and can lead to a significant increase in internal and external failure costs as defective products reach customers. It also undermines the concept of continuous improvement by failing to gather data on potential issues. Another incorrect approach that prioritizes reducing prevention costs by cutting training programs is also professionally unsound. Prevention is a cornerstone of quality management. Reducing investment here directly increases the likelihood of errors and defects, leading to higher failure costs and a decline in product quality. This approach neglects the long-term benefits of a well-trained workforce in maintaining high standards. A third incorrect approach that advocates for accepting a higher level of defects to speed up production is fundamentally flawed. While efficiency is important, accepting defects as a trade-off for speed directly leads to increased rework, scrap, warranty claims, and customer dissatisfaction, all of which represent significant failure costs and damage the organization's reputation. This approach is antithetical to the principles of quality management and continuous improvement. Professionals should employ a decision-making framework that first identifies the root causes of quality issues and then evaluates potential solutions based on their impact on the total cost of quality and overall customer satisfaction. This involves understanding the interdependencies between different quality dimensions and cost categories, and prioritizing investments in prevention and appraisal to achieve long-term cost reduction and product excellence. Consistent with CPIM principles. Question 14. System analysis indicates that a company is experiencing significant variability in its inbound freight costs and delivery lead times for critical raw materials. The current practice involves shipping smaller, frequent orders via expedited parcel services to maintain inventory levels, despite the high per-unit cost. The company is seeking to improve its transportation management strategy to enhance cost-effectiveness and reliability. Which of the following approaches best aligns with the principles of effective transportation management as outlined in the CPIM framework? Option A. Focus solely on negotiating volume discounts with existing expedited parcel carriers to reduce the per-shipment cost, without re-evaluating the fundamental choice of transportation mode or consolidation strategies. Option B. Conduct a thorough analysis of the product's demand patterns and lead time requirements to determine the optimal balance between inventory holding costs and transportation costs, exploring options like less-than-truckload (LTL) or full truckload (FTL) shipments for consolidated orders, and evaluating the trade-offs between different transportation modes, e.g., rail, ocean, air, truck, based on cost, speed, and reliability. Option C. Immediately switch all inbound shipments to a single, lower-cost carrier that offers a flat rate per pound, regardless of shipment volume or destination, to simplify the billing process and achieve predictable costs. Option D. Increase the frequency of expedited parcel shipments to ensure that inventory levels are always above the desired safety stock, thereby eliminating any risk of stockouts, even if transportation costs escalate. The correct answer is B. Conduct a thorough analysis of the product's demand patterns and lead time requirements to determine the optimal balance between inventory holding costs and transportation costs, exploring options like less-than-truckload (LTL) or full truckload (FTL) shipments for consolidated orders, and evaluating the trade-offs between different transportation modes, e.g., rail, ocean, air, truck, based on cost, speed, and reliability. Explanation. This scenario presents a common challenge in supply chain management, where balancing cost efficiency with service level requirements is paramount. The professional challenge lies in selecting the most appropriate transportation mode and strategy without compromising delivery timelines or incurring excessive costs, all while adhering to the principles of the APIC CPIM framework. The CPIM framework emphasizes a holistic approach to production and inventory management, which extends to the effective management of inbound and outbound logistics. The correct approach involves a comprehensive evaluation of transportation modes based on their inherent characteristics, such as speed, cost, capacity, and reliability, in conjunction with an analysis of the specific product's requirements and the customer's expectations. This includes considering freight consolidation opportunities to reduce per-unit costs and optimizing routing and scheduling for efficiency. The justification for this approach is rooted in the APIC CPIM body of knowledge, which advocates for data-driven decision-making and the application of best practices to achieve operational excellence. Specifically, the CPIM curriculum stresses the importance of understanding trade-offs between different logistics strategies to align with overall business objectives, such as customer satisfaction and profitability. This aligns with the ethical responsibility of a CPIM professional to act in the best interest of their organization by optimizing resource utilization and minimizing waste. An incorrect approach would be to solely focus on the lowest cost transportation mode without considering its impact on delivery times or product integrity. This fails to meet the APIC's CPIM principle of balancing cost with service and could lead to customer dissatisfaction, lost sales, and damage to the organization's reputation. Ethically, it represents a failure to adequately assess and mitigate risks associated with transportation. Another incorrect approach would be to prioritize speed above all else, selecting the fastest but most expensive mode without evaluating if such speed is truly necessary or cost-justified. This disregards the APIC's CPIM emphasis on cost optimization and efficient resource allocation, potentially leading to unnecessary expenditure and reduced profitability. It also fails to consider the potential for overinvesting in transportation when slower, more economical options would suffice. A third incorrect approach would be to ignore freight consolidation opportunities, opting for less than truckload (LTL) shipments for every order regardless of volume. This directly contradicts the APIC's CPIM principle of seeking efficiencies through strategies like consolidation, which can significantly reduce transportation costs and environmental impact. It demonstrates a lack of proactive management in optimizing logistics operations. The professional decision-making process for similar situations should involve a structured evaluation framework. This includes 1. Clearly defining the transportation requirements, e.g., urgency, fragility, volume, destination. 2. Researching and comparing the characteristics and costs of available transportation modes. 3. Assessing opportunities for freight consolidation and multimodal strategies. 4. Evaluating routing and scheduling software or methodologies for optimization. And 5. Making a decision that best balances cost, speed, reliability, and customer service, aligning with the organization's strategic goals and the principles of effective supply chain management as taught in the CPIM program. Question 15. Research into best practices for supply chain performance measurement within a production and inventory management context reveals several potential approaches to selecting key performance indicators, KPI. A company is seeking to enhance its operational efficiency and customer satisfaction. Which of the following approaches represents the most effective strategy for selecting and utilizing supply chain KPIs? Option A. Select a broad range of metrics that cover all conceivable aspects of the supply chain, without a clear focus on how these metrics will be analyzed or used to drive improvement. Option B. Focus on selecting a limited set of critical KPIs that directly measure progress towards strategic goals, are actionable, and can be benchmarked against industry standards to drive continuous improvement. Option C. Adopt KPIs that are primarily driven by external reporting requirements, even if they do not provide sufficient insight into internal operational performance. Option D. Prioritize KPIs that are easily quantifiable and readily available from existing systems, even if they do not directly correlate with strategic objectives or operational bottlenecks. The correct answer is D. Prioritize KPIs that are easily quantifiable and readily available from existing systems, even if they do not directly correlate with strategic objectives or operational bottlenecks. Explanation. This scenario is professionally challenging because selecting appropriate supply chain key performance indicators, KPI, requires a nuanced understanding of how different metrics align with strategic objectives and regulatory expectations within the production and inventory management context. The challenge lies in moving beyond superficial measurement to a deep analysis of what truly drives performance and compliance. Careful judgment is required to ensure that chosen KPIs are not only measurable, but also actionable, relevant, and contribute to the overall health and integrity of the supply chain, as mandated by industry, best practices, and potential regulatory oversight. The correct approach involves selecting KPIs that directly reflect the efficiency, effectiveness, and responsiveness of the production and inventory management processes, while also considering their alignment with broader business goals and any applicable industry standards or guidelines. This approach is right because it focuses on actionable insights that can drive continuous improvement and demonstrate accountability. For example, measuring inventory turnover rate provides insight into how effectively inventory is being managed, directly impacting working capital and storage costs. Similarly, On-time delivery rate is a critical indicator of customer satisfaction and operational reliability. These KPIs, when tracked and analyzed, allow for proactive identification of bottlenecks and inefficiencies, fostering a culture of data-driven decision-making that is fundamental to effective production and inventory management. This aligns with the principles of APEX, now ASCM, body of knowledge, which emphasizes the importance of performance measurement for operational excellence. An incorrect approach would be to focus solely on metrics that are easy to collect but have little bearing on actual operational performance or strategic objectives. For instance, measuring the total number of purchase orders processed without considering their value or impact on lead times provides a superficial view of activity rather than performance. This fails to offer meaningful insights for improvement and can lead to misallocation of resources. Another incorrect approach is to select KPIs that are not consistently defined or measured across different departments or time periods. This lack of standardization undermines the reliability of the data and makes benchmarking and trend analysis impossible, hindering the ability to identify systemic issues or successes. Furthermore, adopting KPIs that are not aligned with industry best practices or the organization's specific strategic goals can lead to a misdirection of efforts and a failure to achieve desired outcomes, potentially creating compliance risks if key operational areas are not adequately monitored. Professionals should employ a decision-making process that begins with clearly defining the strategic objectives of the production and inventory management function. This involves understanding what success looks like for the organization. Next, they should identify potential KPIs that could measure progress towards these objectives. This stage requires a thorough understanding of the operational processes and the data available. The chosen KPIs should then be evaluated for their relevance, measurability, achievability, realism, and time-bound nature, SMART criteria. Finally, a process for regular review, analysis, and action based on these KPIs should be established, ensuring that the metrics are used to drive continuous improvement and inform strategic decisions. Question 16. To address the challenge of integrating a new manufacturing execution system, MES, with existing enterprise resource planning ERP, and diverse shop floor equipment, which implementation strategy best ensures data integrity, operational continuity, and the realization of intended production and inventory management improvements within the CPIM framework? Option A. Prioritize the integration of the MES with the ERP, focusing on historical data migration rather than real-time data exchange, and assuming shop floor data will be accurate enough for operational decision-making without direct system integration. Option B. Implement a phased integration approach, prioritizing core data flows and functionalities, utilizing standardized middleware for connectivity, and conducting rigorous testing at each stage before proceeding to subsequent phases. Option C. Execute a Big Bang integration, attempting to connect all MES modules to the ERP and all shop floor equipment simultaneously, with minimal pre-implementation testing to expedite the go-live date. Option D. Deploy the MES with a primary focus on ERP integration, deferring the integration of shop floor equipment until after the initial ERP connection is stable, and relying on manual data entry for shop floor activities. The correct answer is B. Implement a phased integration approach, prioritizing core data flows and functionalities, utilizing standardized middleware for connectivity, and conducting rigorous testing at each stage before proceeding to subsequent phases. Explanation. The scenario presents a common challenge in manufacturing environments, integrating a new manufacturing execution system, MES, with existing enterprise resource planning ERP and shop floor equipment. The professional challenge lies in ensuring seamless data flow, maintaining data integrity, and achieving the intended operational improvements without disrupting production or compromising compliance. Careful judgment is required to select an integration strategy that balances immediate needs with long-term scalability and adherence to industry best practices, which are implicitly guided by the principles of efficient production and inventory management as taught in CPIM. The correct approach involves a phased implementation that prioritizes critical data flows and functionalities, utilizing standardized interfaces and middleware where possible. This approach is justified by the CPIM framework's emphasis on systematic process improvement and risk mitigation. By starting with essential integrations and validating each step, the risk of widespread disruption is minimized. Furthermore, focusing on standardized interfaces, aligns with the principles of interoperability and data accuracy, crucial for effective production and inventory management. This methodical approach ensures that the MES effectively supports production planning, execution, and control, leading to improved visibility and decision-making, which are core CPIM objectives. An incorrect approach that focuses solely on a big bang integration without thorough testing, or a phased rollout, is professionally unacceptable. This would likely lead to significant production downtime, data corruption, and a failure to realize the benefits of the MES, directly contradicting the CPIM goal of optimizing operations. Another incorrect approach that neglects the integration of shop floor equipment with the MES would result in a system that lacks real-time data, rendering its execution monitoring and control capabilities ineffective. This failure to capture accurate shop floor data undermines the very purpose of an MES and violates the principles of effective inventory and production management. Finally, an approach that bypasses data validation and cleansing before integration risks introducing inaccurate information into the ERP system, leading to flawed planning and decision-making, which is a direct contravention of sound inventory management practices. Professionals should employ a decision-making framework that begins with a thorough assessment of current systems and business requirements. This should be followed by a detailed analysis of potential integration strategies, considering factors such as system compatibility, data integrity, risk of disruption, and long-term scalability. A pilot program or phased implementation is often the most prudent path, allowing for iterative testing and refinement. Continuous communication with all stakeholders, including IT, operations, and management, is essential throughout the process. Question 17. Analysis of a proposal to immediately cease all ongoing lean initiatives, including Kanban systems, cellular manufacturing, total productive maintenance, TPM, programs, single-minute exchange of die SMED projects, and Poka-yoke error-proofing implementations, based on a directive to reduce operational expenses by 15% in the next fiscal quarter, requires a thorough evaluation of the potential risks and benefits associated with each tool's discontinuation. Which of the following represents the most professionally responsible course of action? Option A. Selectively discontinue only those lean initiatives that appear to have the highest direct cost associated with their implementation, without a comprehensive analysis of their impact on operational flow or quality. Option B. Delegate the decision to discontinue lean initiatives to line supervisors, allowing them to make individual choices based on their immediate departmental pressures, without a unified organizational strategy or risk assessment. Option C. Immediately halt all lean initiatives to achieve the mandated 15% expense reduction, assuming that these programs are discretionary and their cessation will not have significant long-term negative consequences. Option D. Conduct a detailed risk assessment for each lean tool, quantifying the potential negative impacts on operational efficiency, quality, and cost, and present findings to management with recommendations for phased adjustments or continued investment where justified. The correct answer is D. Conduct a detailed risk assessment for each lean tool, quantifying the potential negative impacts on operational efficiency, quality, and cost, and present findings to management with recommendations for phased adjustments or continued investment where justified. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for cost reduction with the long-term strategic benefits of implementing lean tools. A hasty decision without proper risk assessment could lead to the abandonment of initiatives that, while requiring upfront investment, are crucial for sustained operational efficiency and competitive advantage. Careful judgment is required to distinguish between genuine inefficiencies and the necessary investments in process improvement. The correct approach involves a comprehensive risk assessment of discontinuing Kanban systems, cellular manufacturing, TPM, SMED, and Poka-yoke. This assessment should evaluate the potential negative impacts on lead times, inventory levels, quality, equipment uptime, and defect rates. It should also consider the loss of accumulated knowledge and the potential for increased waste and rework. The regulatory framework for CPIM, while not a direct regulatory body in the legal sense, emphasizes ethical conduct and professional responsibility in inventory and production management. Ethically, a professional has a duty to act in the best interest of the organization, which includes safeguarding investments in proven improvement methodologies and avoiding decisions that could jeopardize long-term operational health for short-term financial gains. Discontinuing these tools without a thorough understanding of their impact would be a failure of professional due diligence. An incorrect approach would be to discontinue Kanban systems solely based on a perceived reduction in immediate inventory holding costs, without analyzing the potential increase in stockouts, expedited shipping costs, and the disruption to the flow of materials. This ignores the fundamental purpose of Kanban in signaling demand and managing flow, potentially leading to greater overall costs and customer dissatisfaction. Another incorrect approach would be to dismantle cellular manufacturing cells without assessing the impact on throughput, work-in-process reduction, and cross-training of employees. This could lead to increased material handling, longer lead times, and a loss of the agility and efficiency gained from dedicated product-focused layouts. Abandoning total productive maintenance, TPM, without considering the consequences for equipment reliability and unplanned downtime is also an incorrect approach. This would likely result in increased maintenance costs due to reactive repairs, production stoppages, and a decline in overall equipment effectiveness, ultimately impacting profitability and delivery performance. Discontinuing single-minute exchange of die-SMED initiatives without evaluating the potential for longer setup times would lead to reduced machine utilization, increased batch sizes, and higher work-in-process inventory. This negates the benefits of increased flexibility and responsiveness that SMED provides. Finally, eliminating Poka-yoke error-proofing devices without a thorough analysis of the current defect rates and the cost of quality issues would be a significant ethical and professional failure. This would likely lead to an increase in defects, scrap, rework, and customer complaints, undermining the organization's commitment to quality and potentially leading to reputational damage. The professional decision-making process for similar situations should involve a structured risk assessment framework. This includes identifying potential risks associated with any proposed change, analyzing the likelihood and impact of those risks, and developing mitigation strategies. For lean tools, this means quantifying the benefits and costs, both tangible and intangible, and aligning decisions with the organization's strategic objectives and ethical obligations to stakeholders. Professionals should advocate for data-driven decisions that consider the holistic impact on the value stream, rather than succumbing to short-term pressures without due diligence. Question 18. The investigation demonstrates that a production supervisor, concerned about a potential disruption due to a perceived low stock of a critical raw material, is considering placing an immediate, large expedited order with a supplier who has also suggested increasing the standard minimum order quantity. The supervisor's primary motivation is to prevent any halt in production. Which of the following represents the most professionally responsible approach to managing this inventory situation, adhering to CPIM Part 1 principles? Option A. Accept the supplier's suggestion to increase the minimum order quantity for this raw material to avoid future perceived shortages. Option B. Focus solely on the potential shortage cost of the raw material and place an order that completely eliminates any risk of stockout, regardless of other inventory cost implications. Option C. Conduct a thorough analysis of current inventory levels against demand forecasts, lead times, and all relevant inventory costs, holding, ordering, and shortage, to determine the optimal order quantity and timing, rather than making an immediate decision based on fear of shortage. Option D. Immediately place a large expedited order for the raw material to ensure production continuity, as preventing a production stoppage is the highest priority. The correct answer is C. Conduct a thorough analysis of current inventory levels against demand forecasts, lead times, and all relevant inventory costs, holding, ordering, and shortage, to determine the optimal order quantity and timing, rather than making an immediate decision based on fear of shortage. Explanation. The investigation demonstrates a common challenge in inventory management, where the perceived urgency of a production delay overshadows a thorough understanding of inventory costs and their impact on overall profitability. Professionals must balance the immediate need to keep production lines running with the long-term financial implications of inventory decisions. This scenario is professionally challenging because it requires a nuanced understanding of inventory fundamentals beyond just counting stock. It demands the application of principles related to holding costs, ordering costs, and shortage costs to make a sound decision that aligns with the organization's financial health and operational efficiency, all within the context of CPIM Part 1 principles. The correct approach involves recognizing that, while avoiding a shortage of raw materials might seem like the immediate priority, the decision must be informed by a comprehensive analysis of all relevant inventory costs. This includes evaluating the holding costs associated with a potentially larger raw material inventory, the ordering costs of placing an expedited or larger order, and the potential shortage costs if the current inventory is indeed insufficient. The CPIM framework emphasizes a holistic view of inventory, where decisions are not made in isolation, but consider their ripple effects on other cost categories and operational objectives. Therefore, a proactive approach that involves analyzing current inventory levels against demand forecasts, understanding lead times, and calculating the total cost of ownership for different inventory strategies is the most professionally sound. This aligns with the CPIM principle of optimizing inventory to minimize total costs while meeting service level requirements. An incorrect approach would be to immediately place a large, expedited order for raw materials solely based on the fear of a production stoppage without a proper cost analysis. This fails to consider the significant holding costs that would be incurred by carrying excess raw materials, including warehousing, insurance, obsolescence, and potential damage. It also overlooks the ordering costs associated with a rushed or larger-than-necessary order. Ethically, this approach could lead to inefficient use of company resources and potentially impact profitability, which is contrary to the professional responsibility of a CPIM-certified individual to manage resources effectively. Another incorrect approach would be to accept the supplier's suggestion of a higher minimum order quantity without questioning its impact on inventory levels and costs. This demonstrates a lack of due diligence and an abdication of responsibility to analyze the implications of such a change. It prioritizes convenience over cost-effectiveness and fails to adhere to the CPIM principle of critically evaluating supplier proposals in relation to internal inventory management objectives. This could lead to unnecessarily inflated inventory levels and associated holding costs, impacting the company's financial performance. A third incorrect approach would be to focus solely on the immediate shortage cost without considering the other components of inventory costs. While avoiding shortages is important, an overemphasis on this aspect can lead to excessive inventory levels, driving up holding costs and potentially leading to obsolescence. The CPIM framework stresses the importance of balancing all inventory cost elements to achieve an optimal inventory policy. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the problem and its potential impact. Second, gather all relevant data, including current inventory levels, demand forecasts, lead times, and cost information, holding, ordering, shortage. Third, analyze the data using appropriate inventory management techniques, even if conceptual for this question. The understanding of these techniques is key. Fourth, evaluate alternative solutions, considering their total cost implications. And finally, make a decision that optimizes for total inventory cost while meeting service level requirements, documenting the rationale for the chosen approach. Question 19. During the evaluation of a new product line characterized by moderate demand variability and a customer expectation for delivery within 2 weeks, which production planning strategy, when integrated with lean manufacturing principles, would best balance responsiveness, inventory management, and efficiency? Option A, engineer-to-order (ETO). Option B, assembled-to-order (AUTO). Option C, make-to-stock (MTS). Option D, make-to-order (MTO). The correct answer is B, assembled-to-order (AUTO). Explanation: this scenario is professionally challenging because selecting the appropriate production planning strategy directly impacts a company's ability to meet customer demand, manage inventory costs, and maintain competitive advantage. A misaligned strategy can lead to stockouts, excess inventory, increased lead times, and ultimately, customer dissatisfaction and financial losses. The choice is further complicated by the need to align with lean manufacturing principles, which emphasize waste reduction and continuous improvement. The correct approach involves selecting a production planning strategy that best matches the product's characteristics, customer order patterns, and the company's operational capabilities, while integrating lean principles. For products with high demand variability and long lead times, an assembled-to-order (AUTO) strategy, when combined with lean principles like reducing setup times and optimizing component inventory, offers a balance. This allows for some level of customization and responsiveness without the high inventory holding costs of make-to-stock (MTS) or the extended lead times of engineer-to-order (ETO). Lean principles are integrated by focusing on efficient assembly processes and minimizing work in progress. An incorrect approach would be to rigidly apply a make-to-stock (MTS) strategy to a product with highly unpredictable demand and long component lead times. This would likely result in significant inventory obsolescence or stockouts, directly contradicting lean principles of waste reduction and efficient resource utilization. Ethically, it fails to meet customer expectations reliably. Another incorrect approach would be to adopt an engineer-to-order (ETO) strategy for a standardized product with consistent, high demand. This would introduce unnecessary complexity and significantly extend lead times, making the company uncompetitive and failing to leverage potential economies of scale, which is contrary to lean objectives of efficiency. Finally, a make-to-order (MTO) strategy for a product with very short customer lead time expectations would be inappropriate. While it reduces finished goods inventory, the extended production lead time would likely lead to customer dissatisfaction and lost sales, failing to meet market demands effectively. Professionals should approach this by first thoroughly analyzing product demand patterns, customer lead time expectations, product complexity, and the cost implications of different inventory levels. Then, they should evaluate how each production planning strategy aligns with the core tenets of lean manufacturing, such as flow, pull, and perfection. The decision should prioritize customer satisfaction, operational efficiency, and financial viability, ensuring that the chosen strategy supports continuous improvement and waste reduction. Question 20. The performance metrics show a consistent disconnect between planned production schedules and actual inventory levels at regional distribution centers, leading to increased expedited shipping costs. Considering the CPIM Part 1 curriculum's emphasis on integrated planning, which of the following best describes the most likely root cause and the appropriate corrective action within a DRP framework? Option A. The transportation carriers are experiencing delays, impacting the flow of goods to distribution centers. The corrective action is to renegotiate carrier contracts. Option B. The DRP system is not accurately translating forecasted demand from distribution centers into gross requirements for the MRP system, failing to account for distribution lead times and safety stock policies. The corrective action is to review and adjust DRP parameters to ensure accurate input to MRP. Option C. The manufacturing facility is experiencing production bottlenecks, preventing it from meeting the demands generated by the DRP. The corrective action is to invest in new manufacturing equipment. Option D. The sales team is not providing timely updates on promotional activities, causing the DRP forecast to be based on outdated information. The corrective action is to implement a more frequent sales data update process. The correct answer is B. The DRP system is not accurately translating forecasted demand from distribution centers into gross requirements for the MRP system, failing to account for distribution lead times and safety stock policies. The corrective action is to review and adjust DRP parameters to ensure accurate input to MRP. Explanation: this scenario is professionally challenging because it requires a deep understanding of how distribution requirements planning, DRP, integrates with material requirements planning, MRP, within a regulated production environment. The challenge lies in ensuring that the DRP process accurately reflects downstream demand and inventory positions, which then directly influences upstream production schedules. Misinterpreting or misapplying DRP principles can lead to significant inefficiencies, stockouts, or excess inventory, all of which have financial and regulatory implications. Careful judgment is required to align DRP outputs with the overall business strategy and regulatory compliance. The correct approach involves ensuring that the DRP system is configured to accurately forecast demand at the distribution center level, considering lead times, safety stock policies, and current inventory levels. This forecast, then, serves as the gross requirements input for the MRP system. This alignment is crucial for regulatory compliance because it ensures that production is driven by actual, forecasted customer demand rather than assumptions. Adhering to the DRP process, as outlined in APEX, now ASCM, body of knowledge which is the basis for CPIM certification, ensures that the planning process is systematic and data-driven, minimizing the risk of non-compliance, due to production of unneeded items or failure to meet demand for critical items. An incorrect approach would be to bypass the DRP process and directly input aggregated distribution center demand into the MRP system, without proper consideration of individual distribution center lead times, safety stocks, or transit times. This failure to accurately translate downstream needs into upstream requirements can lead to production of items that are not yet needed at specific distribution points, or a lack of production for items that are critically low. This violates the principle of efficient resource allocation and can result in inventory obsolescence or stockouts, potentially impacting customer service levels and leading to regulatory scrutiny if the products are subject to specific delivery or availability mandates. Another incorrect approach would be to treat DRP as a purely inventory management function, disconnected from the production planning. This disconnect means that the MRP system might not receive accurate gross requirements, leading to suboptimal production schedules. This can result in either overproduction, leading to excess inventory that may have shelf life limitations or require specific storage conditions, and thus regulatory oversight, or underproduction, leading to shortages that could violate contractual obligations or service-level agreements, which may have regulatory implications. A third incorrect approach involves relying solely on historical sales data for DRP inputs without incorporating forward-looking demand signals or promotional plans. This static approach fails to capture dynamic market changes or planned sales activities, leading to inaccurate demand forecasts. In a regulated environment, this can result in the production of goods that do not meet anticipated market needs, leading to waste and potential noncompliance with demand-driven production mandates. Professionals should employ a decision-making framework that prioritizes understanding the end-to-end supply chain flow. This involves 1. Clearly defining the role of DRP in translating customer demand at the distribution level into actionable production requirements. 2. Ensuring the DRP system is accurately configured with all relevant parameters, lead times, safety stocks, etc. 3. Validating the DRP output as the primary input for MRP. 4. Regularly reviewing and adjusting DRP parameters based on performance metrics and market intelligence. This systematic approach ensures that production plans are robust, responsive, and compliant with the overall operational and regulatory framework.